Alright, welcome back everybody. So what I want to do in this video is basically give an overview of the different software development processes we might use. Here I'm using the word, there's also the word kind of models there. That's just as kind of a reminder that, hey, we're going to be talking about these things at a high level. So we're not going to be talking about, specific roles or specific deliverables. We want kind of a bird's eye view of all these things. That way we can kind of discuss them in a reasonable amount of time and later basically kind of compare and contrast these. So basically what I'm going to be doing here is I am going to be discussing these things as, what they are, right? So I will give an overall description of them. I'm not going to be talking about advantages or disadvantages because that's something that I think you guys, with your kind of perspective, having been through several, years of classes from, different projects, hopefully that's stuff that you guys can basically reason through on your own, right? Or at least have some ideas of, oh, hey, I think this is probably how it works, or, this, maybe it won't work. And those are really the ideas I'd like to see, right? Is you guys basically taking your knowledge, right, and trying to apply it in terms of understanding what processes mean, right? And at the end of the day, right, maybe doing something like selecting a process, right? Maybe even for your project. So let's go and get started. The first thing I want to talk about is basically the process you never want to use, or well, you may want to use it, but I do not want you to use this. Nobody at our department wants you to use this. This is basically the good old what you did in SER401 or CST100 when you first started our program. So this is what we call the build and fix approach. So build and fix approach, I want to kind of narrate this. You probably look at your homework assignment and you say, oh, I want to I need to do this or I need to write this code. And so you say, okay, I'm going to build, I'm going to write all this code and basically build a solution to that. Okay, you write 500 lines of code. And then you see, hey, let me double check the requirements the instructor gave me. Let me double check the test case they gave me. Do they pass or do they not pass? And if they don't pass, well, you got to go back to that code you built and then all of a sudden, do some little revisions in there and hopefully, now it works, right? So check it again. And there's basically this loop where, oh, yeah, this kind of monolithic thing that I built, I'm just going to see if it kind of meets what the expectations are. And if it does, then I can move on. Otherwise, I need to kind of adjust stuff and adjust stuff, and I'm going to kind of cross my fingers. Oh, hey, I'm hitting everything that the instructor wants. Then eventually, right, we have here in the diagram operations mode. So operation mode is really, oh, hey, I gave it to the instructor to grade, right? So that's operations. There is no client here, right? There is no end user. All it happens is that once you're done meeting all of the requirements that you can tell from the assignment, you pass it to us to grade, right? And you get back some feedback that says, okay, hey, it didn't work. You're 0 out of 100, or oh, here's 100. Everything worked fine. And then after that, that's end of story, right? Retirement. That file that you wrote basically is going to sit in your Dropbox or sit in your own private GitHub repository until the end of time, right? Because no one will ever ask to see it again, unless it was maybe a really cool project, in which case maybe you want to put in your resume or something, or mention it to people. But that's about what happens, right? So you basically build a thing, adjust it until you're pretty sure it works, then ship it to us, and then we tell you yay or nay, and then it gets put on ice for the rest of eternity. So this is called build and fix. So this is one approach. Please don't use it. Hopefully you guys can see that there's going to be some issues with this, okay? I mean, maybe there are some advantages. Maybe you guys can come with those advantages, but for sure there's going to be many, many disadvantages. Let's go ahead and jump forward now to the next one, which is going to be waterfall model. So this is something hopefully you guys are familiar with. I think you guys will be from one of the software enterprise courses. You may not have used this on a project, but I know you guys should have seen this before. So this is waterfall. It's very kind of, well, I want to say common, not so much common in terms of usage, but in terms of everybody knows about it and everybody kind of builds from it or keeps it as an option that they could use. So in waterfall, basically what we're saying is the following. I am going to define specific steps, right, specific phases in my development. And you can just I'll just even read them here for a second, right? So we have things like requirements definition, system and software design, implementation, unit testing, integration and system testing, operation maintenance. These are all well-defined phases that are going to be involved during my project's development. So when I say well-defined, actually let me expound on that a little bit. So well-defined is, well, I have specific things I need to do, right? I have kind of specific deliverables for each of these phases. And these phases are all meant to basically be non-overlapping. So once I finish so I look at my requirements, I define them right, and then I'm done, right? I pass it along to systems design. I never return the requirements to revise everything. I do these kind of one at a time. And then basically there's no kind of overlap, so these are kind of very much distinct or discrete steps, right? I go one by one by one. And you can kind of see, right, there's the graphic, right, of the waterfall flowing, right, which is how the name comes about. Okay, so I'm doing these things one at a time. This is, well, again, I don't want to talk about advantages and disadvantages too much, but there are basically places where this thing is a good idea and things where it's a bad idea. Maybe an observation, right, is this is very static, right? I do have kind of the arrows here saying, oh, hey, I can come back, but notice that these are basically partitioned into, okay, I've already shipped a version of software, right? I maybe need to do some maintenance. I need to do a version 2. That's when I get the opportunity basically to return these things. But inside of a single project, it's expected that I basically carry these things out independently, right, in order, right, and just do it once, right? And so there's always this downward flow of, oh, I've accomplished this, and now I move on to the next thing. So that's the waterfall model. Let's see. Let me actually spend a second to maybe talk about these. So things like, for example, requirements definition, right? So maybe that's working with our client, basically determining what are our functional requirements, what are our non-functional requirements, right? Trying to identify maybe sample users, right? Maybe we're using something like personas and define use cases, all that stuff basically to understand our problem better. System and software design, well, that's kind of the analysis step, right? And analysis and design, right? Those two things go together. Take a look at what our requirements are and try to determine what would be an appropriate architecture to use there, right? Or appropriate technology to build on, right? That's what we need to do in terms of design analysis. Implementation, unit testing, well, that's now we've have a complete design, hopefully. Well, the assumption here, right, this is a waterfall, is that the design produced in the earlier step, right, step 2, is basically done, right? I can hand it off to somebody and say, okay, implement this, and they can do that. Whether this is realistic or not, you guys can maybe think about it. Okay, fine, hint, it's not. A lot of times, right, we don't really fully understand a problem or how we solve it until we actually try to solve it. And so that doing all the upfront design work and analysis work, well, I mean, we can do it, but sometimes there may be some issues. So anyways, implementation, right? Going from that design, generating something that's an actual implementation, right? An actual sample product, maybe some sort of an alpha level piece of software. And then from that, right, we can look at our requirements and start to do some testing. Once we're done with that, right, once we have our piece of software implemented and we've tested it sufficiently, then we can look basically at integration and systems testing. And maybe I should back up a second. So the previous step, right, that's step 3. When I say implementation, usually implementation is somehow on a component level. So my system may be broken into a couple dozen components or a couple hundred components, whatever, depends on your level of abstraction. And each of those components is going to have test cases for them, right? And we can kind of develop each of those things. Right? We have design that says, oh, I do need all these components, right? So I'm safe to develop them all. And so I can do that, right? And then basically look at my test cases, right, that I create for these or whatever, and then validate or verify, right, that they work as I intended, right? And then later on, I move to basically systems integration, where all those different components that my design proposed, I try to put those together, right, in the way, again, that the design proposed, and then verify that it's working appropriately. Okay, so maybe there's kind of 2 levels of abstraction there in the diagram. Last thing there, right, is operations and maintenance, right? So this is basically everything else. This is typically the kind of the biggest time investment here in this graph of saying, okay, now we've taken this product, we're putting it on the market. We need to worry about things on how do we deploy, right? How do we get to the customer? How do we get to the client? How do I maintain it? How do I basically push updates? How do I keep this thing alive? Okay, so that's waterfall. Again, just think discrete steps, all independent, and have to happen one after another. So coming to the next slide, we have the V model, which is really an extension of the waterfall model we just talked about in the previous slide. So in V model, well, actually, let's jump back to waterfall for a second. So one of the issues here in waterfall is the following. We do our requirements gathering, we do our systems design, we do our implementation, we do integration, and then we have some testing left to do, right, if we follow this flow. Sometimes what happens in a waterfall kind of scenario is that's where we run out of time, right? We've invested all of our time in the other steps, we get down to testing, all of a sudden it gets kind of squeezed down, right, until I don't have all that much time and money left. How do we fix that? One approach is basically baked into the V model. So V model, basically some of the steps look like what we saw in waterfall. So we have over here things like requirements engineering goes down to systems design, software design, coding, right? So this is somehow looking a little bit like that waterfall flow, right? What I've illustrated here. So you can think about these things, right? These are different phases that are happening, right? So these are phases PH. I'll just write PH. These are different phases that are maybe happening in software development. So this part maybe looks a little bit like the waterfall model. So what's different here? So what's different is that in this diagram, we are kind of implicitly doing things in parallel. And I could, I suppose, add this here. I could add this little bar, basically say there's, time is happening, right? Time, come on, time is passing. Starting at 0 and going to, I guess I'll go ahead and do what the previous notation I used was which was I just put end over here. So end, right? So time from 0 basically to the end of the project. So we start with requirements, then we move to system design, then we move to eventually coding. So the idea here, right, is that kind of that kind of waterfall flow is basically shown on the left-hand side, and the right-hand side, what we have is basically testing happening in parallel. So as we do something like requirements engineering, right, maybe we try to figure out, okay, these are the requirements that I need, right? This is what I got from the marketing folks or the business folks. How do I validate that the end product that I have developed is actually going to suit those specific needs, right? I want to validate that I've built what I'm supposed to have built. Well, what I can do basically is, after that phase of requirements engineering, right, gathering my requirements, is I can say, okay, I'm going to have a couple people go and basically work on some set of tests. I don't know if I really want to use that term, but basically some way to check that, right, to check that I've done the right thing, right, to validate my requirements. And I can basically spin them off and have them work on that in parallel with my development proceeding. So that's where this kind of V shape is coming from, right? This stuff over here is happening at the same time that this stuff over here is happening. Right, so I have basically my requirements gathering happens, right, and as it happens, I'm starting to move down the V. But basically, in addition to pushing that information, those requirements forward to design, it's also going over to systems validation, right? So people can look and say, okay, this is how we're going to validate the product at the end of the day, right? So you already have people kind of preparing for that. And then moving down, the same kind of pattern happens. So you go to systems design. While you do systems design, you should also have people that take a look at what that design is and try to figure out how do they verify it, right? What sort of kind of test plans should they put together in order to do that? And again, it's something that basically happens in parallel, right? As you design your system, right, once you have some stuff there to work with, you can pass off to somebody else, and they can go ahead and get started with some ideas on how to validate this thing, how to verify this thing. Verification, right, is really when you say, okay, I have some specific metrics, right? I need to hit these specific things, right? I need to implement this component with this behavior, right? Or I have this function that needs to have this output and these specific inputs, right? That's verification, right? We have kind of a knowns versus validation is when we say, oh, hey, kind of a little bit more of a fluffy thing where we say, okay, did we actually do what we were told to do, right? Versus did I engineer my component the way the spec said it's supposed to be, right? That would be verification. So again, right, we do some system design, and in parallel, we hand it off to somebody else, right? So so we don't only move forward with basically later stages of design, later stages of coding. We're handing it off to somebody to basically decide how are we going to validate that thing later. So how are we going to verify that thing later? So the flow continues, right? We go to software design, kind of similar to systems design, different level, then to coding, right? And so coding is at the point basically where we're at our lowest level of granularity, right? We have all that design analysis behind the scenes, and hopefully, right, we can do our coding, and as soon as we're done coding, oh, hey, I have basically my entire hierarchy of things to test, right? So I have stuff to basically do my verification, my software design, verification, my systems level design, and then validation of the system in terms of the business requirements. That's all kind of there, right? Because I was already working on that stuff. So hopefully, I'm not going to kind of get squeezed and say, okay, this is the end of the project. I need to get all my testing in from scratch. No, the idea is here we've done some stuff up front, right, in order to basically make our lives easier for when we get something that we can actually run, and then kind of execute those tests that we've already developed, and hopefully things go well for us. So that's the idea of a V model. Basically, it's going to be waterfall with some additional kind of space in there, if you would, for making sure that we have appropriate time to design and basically plan our test process for this piece of software. Okay, so taking a look at another approach, this is the spiral model. So the spiral model is ultimately all about risk. So looking at this picture here, I'm basically beginning over here. Right? This is my starting place. This is maybe start. And now what's happening is that basically in this graph, each of these circles, right, they're basically comprising my spiral. Each of those is representing basically a phase. Now, it's not a phase in terms of the waterfall model where we say, okay, this is for requirements, this is for design, this is for implementation. Each of these phases, if you would, each kind of 360 around the spiral, the phase basically in terms of how deep we've gone to the project. So maybe the first phase is something like requirements, next phase is maybe basic architecture, third phase could be implementation. That's how they're basically being shown here on this graph. So looking at this thing, they're kind of 4 quadrants. So we have basically quadrant 1, quadrant 2, quadrant 3. I feel like I'm not numbering these the way that the mathematicians would, but it's fine. So we have kind of these 4 divisions here. And you'll notice, right, if you're tracing this line in your head, right, this line is representing basically a product kind of lifetime. This line here, you'll notice it goes through all 4 quadrants. So what do those quadrants mean? So initially, right, you start with by this kind of quadrant 1, which says basically determine objectives, right, alternative constraints. So basically, we need to define what it is that we want to do, right? What is it? Are we trying in this phase, right, this kind of segment of this file to gather requirements and maybe put together a prototype or something like that? What is it that we want to do, right? So that's kind of a gimme. Evaluate alternatives, right? So maybe we do, kind of multiple designs, multiple prototypes, right? And also as we do this, kind of the big part here is this over here. Well, I should say, what makes this model distinct from the other models? Is this part over here? It says resolve risks or risk analysis. So basically, after we define what it is that we want to do, the kind of the immediate step, right, which you'll see on the graph here, is this risk analysis to basically say, okay, you want to do this, right? You want to, develop a user interface. What are the risks involved, right? So maybe the risks are, oh, hey, the user, right? I don't know them very well. I don't understand them very well. I'm afraid that perhaps, right, the interface that I propose, they may not like it, right? Maybe that's a risk I can identify, right? A very top level one. I want to basically say, for whatever objective I'm trying to address, right? What are the potential risks involved? Because once I kind of identify that, I can figure out how to mitigate it. So if my risk is that I don't understand my user, well then maybe I want to think to myself, oh hey, later on when I get to development, I don't want to make this super polished user interface to give to them and find out what they think about it, right? To basically get feedback from it. Really want to do is I want to have some throwaway prototype, right? That's very low investment because I'm pretty sure, right? Well, there is a large chance, right, that the user won't like it and I will have to go back to the drawing board. So I don't want to invest my resources there. So again, right, that's basically what we're trying to do here, right? In this model, we're trying to identify risk and find some way to address it. We don't want it basically to waste our resources. So looking down at the next quadrant, which is quadrant 4, this is development, right? So we've decided what we want to do. We've kind of analyzed the risks. We know what are going to be the safe moves to make, right? And we can go do it, right? Maybe we build a prototype. Maybe we talk to users, right? We'll do some additional requirements gathering, whatever, right? But we do what we need to do. Last step here, right? Plan next phase. So basically identify, what have we done? Maybe it happens to be the case we're done, right? So eventually there's going to be some final spiral, in which case we basically implemented what it is that our requirements said we can do, and then we can stop, right? Otherwise, right, basically you're going to have to take another loop around and basically go and do this, determine objectives, evaluate alternatives, resolve risks, do this kind of cycle again. So just going through here, right, so really quick, right, you can basically see our spiral begins, right, we kind of figure out, what it is, try to understand our problem, review what's going on, do some risk management, maybe a prototype, right, implement it, circles around, right, we do the same thing over again, right, we kind of redefine objectives, do more risk analysis, make sure nothing new has come up, right, prototype again, get to maybe, some kind of deeper development. Remember that as we kind of move out, right, as we move out like this, we're basically showing a kind of a more mature development, right? So we're moving from basically this requirements gathering, which maybe happens in the very center, right, where it's all about trying to understand what we're doing. First, as we move out, we start building more and more concrete parts, right? So it's kind of this maturity that goes from inside to outside, and overall, right, we're repeating these 4 steps. So it's very much an iterative process here. So next up is Rational Unified Process, or RUP, or maybe just say RUP. Okay, so this here, I'm going to be a little bit general here because this is somewhat of a customizable process. So let's take a look at what we have here. Again, right, we have the basic notion of phases, right? So you can see on the top, right, we have basically these 4 things listed out: inception, elaboration, construction, and transition. So kind of to link these into the things we did before, inception is somehow similar to maybe requirements, maybe a little bit of systems design, right? If we think back to the waterfall kind of process, right? Basically, right, it's when our project is first starting, right, we kind of need to identify, what it is that we want to build, what are maybe some general approaches, right, just to get started. The next one, right, is elaboration. Elaboration, right, is really full-on design, right, trying to identify specific use cases, right, trying to identify specific system elements, right, trying to break that down even further and identify, what potential designs, right, potential architectures. That's what elaboration is all about. Construction is pretty much let's go and code it, right? So now we have a working design from elaboration. So let's, basically throw it over. Well, I don't want to say throw it over the wall. It's not. That's a different term, or for a different process. That's what they say about waterfalls. They sometimes say about throwing it over the walls when you go to, from one stage to another stage as you move down that particular process. But anyways, this is a little bit different. So construction, anyways, is basically going to be, okay, now we turn it over to people to actually do the implementation. Right? We have a design, we have our requirements, we need to build the thing. Transition is basically this idea of transitioning, right? The process of going from, oh, hey, we've just built this thing, we have a piece of software at our company. How do we transition to being in the field, right? Transition to being a product on the shelf. So those are overall phases here. So it's a little bit different alignment than the ones we've talked about before. They're a little bit more general somehow. Now, what RUP basically defines, right? It is basically, well, it does a lot of things. But if we look at kind of a graph and try to understand in terms of that, we can see on the left side it talks about workflows. So basically what that's saying is that this kind of activity is going to be active, right? People are going to be working on this. So if you look at our graph there, you can see that, for example, our first workflow over here, right, our business modeling, if I look at my graph on the right-hand side, which is really over time, right? So this is, again, this is over time. I'll add an arrow here, right? So this is time 0, time done. I need to find another kind of term here other than just writing done every time. This is how I can kind of picture my project living, right, what happens. So the first workflow there it's happening is my business modeling. With business modeling, you can see basically there's a lot of area under the curve there for inception. The area under the curve is basically work or effort, right? So a lot of that happens during inception, right? So we try to understand our problem domain, try to understand the piece of software that we're trying to build, right? And that still happens throughout our design, right? Because we need to make sure that we understand our problem appropriately, right, as we build a solution to it, right? It's not kind of a hands-off thing, right? You still go back to it. Looking down there, you can look at the requirements, right? So the requirements you can see is kind of in the inception part as we first kind of come up with our product. It's still there in requirements, and it's going to kind of hang around through construction as things come up that we didn't really foresee. You can kind of just walk down this. Most of these are kind of common terms. You can maybe think to yourself, oh, hey, how would these maybe be important for a specific phase that the RUP has? Right. So these are all going to be pretty familiar to you guys, right? Basically things that could happen during your project. Real quick here, the last one here, environment, which is maybe something you hadn't seen before. Environment is basically saying, okay, you're gonna have to spend time to set up stuff, right? Set up your environment, right? Maybe you need hardware for testing, you need to set that up. Maybe you need to get certain tool chains installed. Maybe you need time to get that set up. So basically, what do you need to have, right, in order to make people productive? So you can see that kind of basically spikes at the beginning of each of these phases because we have to set the scene for people to do their job. Okay. So basically, right, this chart is showing our overall phases, right, how things kind of, how effort is spread out. One thing here that this chart is showing that's not really clear from just the chart itself is that each of these are basically meant to be iterative. So you start here in inception, right, and maybe you, instead of just, doing inception once like this, you say, okay, I can go through it, and then I basically repeat it, right? Same thing holds for all these other ones. So elaboration, repeat it. Construction, repeat it. So within each of these phases is meant to be iterative. Also notice here, right, that these phases aren't necessarily pure, right? So I'm really actually having an opportunity to really do multiple things. So if if I look here, I say elaboration. I say, okay, elaboration, I'm going to do some iteration there, right? I'm going to go through that phase again. I'm not just getting a chance to do implementation again. I'm not just getting a chance to do analysis and design again. Really what we're saying is, okay, yeah, I can expect to revisit the requirements a little bit. I can expect to revisit business modeling a little bit, right? So things are a little bit blended together here. And then eventually, right, I can even think of, this whole process, right, as a whole, right, maybe this repeats as well, right? This could also be iterative. Okay, so that's kind of the view of RUP, right? So basically, it's maybe a different side, a different division, right, of work, and also kind of recognition, right, there is some overlap. Now, behind the scenes, there is a lot more, but I don't really want to get into it. A lot of it comes from basically this view of how do we monitor our process, right? How do we structure it? There's a lot in there about basically, we need to document things in a certain way, right? We need to basically use UML to describe our system. There's also tools by IBM to basically manage all this process. But kind of that level of detail is just a little bit more than what we need right now. The last thing I want to talk about is Agile, and specifically we're going to take a look at Scrum just as a sample here. Scrum is hopefully something you guys are familiar with from one of the previous classes. Hopefully, right, when you took SER401, you had an opportunity to try Scrum for yourself or some other Agile process. So let's take a look in terms of Scrum. How does Scrum work? So Scrum is all of a sudden this is going to be structured a little bit different than the other things we've talked about. So initially, right, we start with this idea of a product backlog. So okay, I have basically some product owner, and product owner has defined, okay, I need X, Y, and Z, right? Features 1 through 20, right? That's our product backlog, right? They're all kind of discretized things, right, that we need to work on. And then we say, okay, what we're going to do is we're going to have a sprint. So sprint is basically our team coming together and working right on this kind of short duration of time to get some subset of that product backlog completed, right? So then we have what is basically called a sprint backlog. So we basically say, okay, for all the things I need to implement, let me select some subset of that, and that's what we're going to focus on, right? We're going to run a sprint. We're going to run a sprint in order to focus on those particular items. And so a sprint, right, may take a couple of weeks, and your team is basically going to be assigned, right? Different people in the team are going to be assigned different items from that backlog based on their capabilities, right? Based on what is needed, right? And then they have basically this couple weeks to go through and work through this, right? And so we have this here, actually, let me make a little correction here, right? So we have basically the sprint backlog of the features we're committed to for kind of this little 3 weeks we're going to spend working really hard on our product. And usually, right, it's something like maybe, let's just say it's like 2 weeks. I think 30 days is a little bit long. So let's pretend that says 14 over there. So basically, right, your team's going to be working on that. And then within that, right, every day you're basically going to have a meeting, right, a stand-up meeting, basically to communicate with people and say, okay, this is what I've worked on, this is what I am working on, this is my concerns, right, maybe there's some issues for me that they're potentially coming up, or maybe they already came up, maybe I think that something I'm working on might impact somebody else. I'm basically, right, to try and keep everyone in the loop with respect to risks that are there in the project, right? What can stop us from moving forward? What can stop us from hitting our goal, right? What can stop us from basically resolving the items or implementing the items that we need to? And typically, right, things are kind of managed by someone called Scrum Master, right, which is in charge of making basically sure the communication goes smoothly. Okay, so all this stuff happens, right? Hopefully 2 weeks roll by and we've managed to clear our basically our backlog, right? Our sprint backlog, and then we can hopefully have right there a product that can be used, right? Maybe it's not perfect, but it's something that is basically whole, right? We want to have a complete product. We want to have something that's immediately usable. And then basically we repeat this over and over again, right? So we pick another subset of items from that product backlog, make that the new sprint backlog, spend another few weeks, right, working on those, right, addressing them, right, producing a new kind of incremental project, right? This is kind of an incremental approach, and repeating again and again and again until we've implemented everything that we've been asked for. Okay, so that's an overview of Scrum, and that kind of covers it for the different processes I wanted to overview. As a final remark here, these are the discussion questions. So this is what I really want you guys to spend some time thinking about, and what I hopefully want to have spend some time talking about, right, later on in the week. So the first thing here is, do you have any experience with these process models, right? So it could be the ones here that's particularly interested in. If you have worked in with other ones that are of interest, I'd like to hear about that too. Basically, right, is hopefully I can get some discussion from you guys in terms of what you have seen out there, right, in your work. I mean, number one thing. Second thing, right, is what are the advantages and disadvantages of these models? So I've described these overall processes. I haven't really said all that much about, this is really nice, this is really bad. I have maybe said a little bit about the motivation. I think maybe I did bash on waterfall a little bit, but I haven't been, too specific about advantages and disadvantages because I want you guys to think about that. Right now, at this point, right, you guys have had the context. You've been through many projects and many classes. Some of these, are a month long. You're about to embark on semester long. You yourself are about to embark on a 2-semester project. So hopefully you have enough context to say, okay, yeah, I can see these issues, right, with this one, or I can see benefits of this other one, right? So that's what I want you guys basically spend a little bit of time thinking about, right, and try to analyze it yourself. The last question here is, can you give an example of a project for which one of these models will do well and which another one might cause issues? So this will probably come for your second question, right, when you identify the advantages and disadvantages. Even kind of envision, what is kind of a project that can use these, right? What's a project that's going to be disadvantaged by these? So think about those, and then we'll have a nice discussion later on in the week on what you guys think.